Hello everyone, in this video I would like to show examples on wavelength and the energy of a photon. Work and solve examples. Calculate the wavelength in nanometer of a red light emitted by a scanner with frequency of 4.62 times 10 to the power 14 per second. So the first thing we need to do is to write a relationship which says frequency is equal to the speed over the wavelength. In this problem, we are looking for the wavelength, so we're gonna rearrange our equation. And the wavelength is gonna be the frequency, the speed of light c over the frequency. Our speed of light is 3.0 times 10 to the power 8 meter per second. And the frequency is given, which is 4.62 times 10 to the power 14 per second. Right, so this we go, and we have our wavelength to be, if you plug this into our calculator, it's going to give us 6.49 times 10 to the -7 meter. However, we are looking for our wavelength in nanometer, and this is a meter. So we say 1 nanometer is equal to 10 to the -9 meter. So we use this to convert. So we have 6.49 times 10 to the -7 meter times 1 nanometer over 10 to the -9 meter. So this is going to give us 6.49 times 10 to the power 2 nanometer, or we can say 649 nanometer. So that gives us our wavelength. That is how we solve this. Make sure you remember your relationship, which is the frequency equals the speed of light over the wavelength. Okay, so let's take a look at another example. Calculate the wavelength of an electron traveling with a speed of 2.65 times 10 to the power 6 meter per second. So because we are talking about wavelength and speed, the relationship that should come to our mind is the using the Broglie wavelength relationship. And this relationship gives us wavelength equals to the Planck's constant or divided by the mass and velocity, which is the momentum. Our Planck's constant is 6.626 times 10 to the -34 kilogram per meter square. Kilogram meter square. Our mass of electron is 9.11 times 10 to negative 31 kilogram. And the speed, which is the velocity, is 2.65 times 10 into 6 meter per second. So when we plug this into our calculator, it's gonna give us 2.74 times 10 to negative 10 meter . So that gives us the wavelength. The question did not ask us to find the wavelength in nanometer, so we can leave our wavelength in meter. So the next example, determine the wavelength of a light emitted by an electron in an hydrogen atom, which makes transition from orbital n equals to 6 to orbital n equals to 5. So the first thing we should do is to write our relationship. So we're going to say our delta E, which is the energy of a photon, is going to be RH into 1 over n initial squared minus 1 over n final squared. Our n initial is 6 and our n final is 5. So we plug that in. Our RH is negative 2.18 times 10 into negative 18 joules. So we have our delta E to be negative 2.18 times 10 into negative 18 and 1 over 6 squared minus 1 over 5 squared. So this is going to give us negative 2.18 times 10 into negative 18 to 0.20278 minus 0.04. So when we plug this into our calculator, it's going to give us positive 2.664 times 10 to negative 20. However, we are looking for the wavelength. We know that our energy delta E is hc over the wavelength, where h is our Planck's constant, c is our speed of light. So when we rearrange our equation, our wavelength, it's gonna give us hc over delta E, and this is going to be 6.626 times 10 into negative 34 joule per second times the speed of light, which is 3.0 times 10 into 8 meter per second. And our delta E is what we already have here, 2.664 times 10 into negative 20 joules. When we plug this into our calculator, it's gonna give us 7.46 times 10 to negative 6 meter. Or we can convert to nanometer, which is gonna give us 7460 nanometer. All right. I hope this helps. Thanks for watching.